Hey everyone, in this video we're going to work through an application of the central limit theorem. So let's get started. Alright, we're going to jump over to the computer and work through an example together, so I'll see you there. Alright, so this isn't much of an application of the central limit theorem, but it is really important to understand. So let's say you're conducting an experiment and this is what the population looks like. Of course, you're not going to know what the population looks like because you're sampling the population and you're using the sample to try to understand the population. But just understand that the population could be really messed up like this. And let's say you're trying to find the average. Well, the central limit theorem states that as your sample size gets larger, then the sample distribution, the blue graph, gets more like a bell curve. Meaning that if we take a small sample, then unfortunately our average could be pretty far off and unpredictably far off from the truth. And let's see kind of that play in here. I'm going to take a sample size of 2. Now, if we go over 100,000 simulations of this is what the distribution would look like. And it's really hard to see our experiment as part of this distribution. It's really hard to even understand what's going on with this distribution, let alone do anything math related. So if we do our sample, which is just one of those, and it's, let's say, this one, well, we got an average. How close is that average? How accurate is that average? It's really hard to say because based on the central limit theorem, because our sample size is so small here, it's really hard to tell whether or not we're close to the truth here, or if our sample is really representative of the population. So if we do a bigger sample size, let's try maybe 5, we might be able to get a better understanding of what's going on. So I'm going to take 5 people here, and there's my average. That average is still far off. It's a little bit to the right of the true average. And unfortunately, because my sample size is too small, it's kind of hard to predict whether or not that is close to 16.53. Because, again, if I do 100,000 of these simulations, it doesn't really look like much of a bell curve. I mean, it kind of looks like a bell curve, but not too much. But this is kind of why we need to take large samples, is because if we don't, then we can't really tell what our sample looks like amongst many samples. But if we take a big sample size, let's try 25, and let's animate these 25 people. We should expect our average to be really close to 16.53, which is the average of the top one. Let's see. It's actually not. Surprisingly, it's not. Again, could be because our sample size is still kind of small. However, we can start talking about what it means to be close to the truth, because if we keep doing this, let's simulate another 5 bricks here. Here's another 5 bricks, another 5 bricks, another 5 bricks, and over 100,000. This looks pretty normally distributed, and it is, in fact. And so we can see whether or not that first brick that we did, and here let's do another brick. Let's actually clear first. And then we're going to drop that blue brick. We'd be able to tell, based off of some mathematics, whether or not this blue brick is actually close to the truth, or what is close to the blue brick. Because keep in mind, again, we have to understand this blue brick is not the true average. It is really, really unlikely that this blue brick is the true average. Might be a little bit off. But the term close can make sense mathematically because this one blue brick is amongst many possible options that could have happened here. And because this is a normal distribution that you're looking at, we can do some math to figure out what close actually means. Anyways, thank you guys so much. I'll see you in the next lecture. You just watched a video from More Learning. We provide free math videos and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. and put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.